Hi, I'm Alan Ross. I'm here at the IEEE PES T&D, that's a lot of acronyms, conference. This is the 2020 version that is actually being held in 2022. These interviews that we're conducting is with thought leaders on the future of the power industry. So enjoy. Hi, my guest at this IEEE event is Jim Seffrin. Jim is the CEO and founder of Introspection Institute. He sponsored a conference that I attended earlier this year, the IR conference, and I met him there for the first time. In his keynote, I think it was one of the first conferences that we came out of the COVID situation with, and Jim got kind of broken up at his keynote dinner where he thanked us all for being there. Jim, it is a delight to have you here today.
Pleasure being here, Alan. Thank you.
So Jim, one of the things that we're doing is we're picking thought leaders to be able to look at the future of the power industry, defined as however you want to define power industry, because some people say, is that utility? What does that mean? Just the power industry. What do you see looking ahead when you talk about the power industry?
Well, the power industry, of course, has been critical to our country and us as all the citizens for many, many years.
Yeah.
Ever since the electrification of the country occurred back in the mid-20th century. The future is something where we have come to expect, in fact, demand reliable power. Perhaps the only utility we have a greater sensitivity to losing in a temporary outage is the internet.
Or water.
Or water.
Yes.
But it's absolutely critical. Everything we do relies on power. And for a nation that's been driven by fossil fuels for so many years, we see now our primary mode of transportation, cars and trucks, now moving towards electricity. So it's absolutely critical and will continue to remain that way for many years to come, I'm certain.
So because we all know that EV is the future, right? I mean, the car companies are doing it. The more cars they bring out and the more cost effective they are, the more people will buy them. But what does that mean for the infrastructure? When we say, hey, we're going to add that much power demand, it's like putting a billion little microwave ovens out into the marketplace, putting them on wheels. What does that look like, do you think, for power demand?
Well, I think that power demand is certainly going to go up.
Right.
We've certainly worked over the last 20 years or so to try and become more efficient. But you look at many locations where there is no redundancy in the power grid or for substations,
right.
For example. So everything is running at capacity, in some cases in excess of capacity,
right.
depending upon the season.
Right.
So we've got to find a way to become more efficient. If there is tremendous resistance to adding new capacity in the form of new generating stations, this is going to be a problem. We're really at loggerheads with the demand versus the capacity.
And therein lies the rub. It is predicted that with the electrification of transportation, I'm not predicting it, other people are, that we're going to double the need of power. And we've been flat. The last decade, demand for power has been pretty flat. There's been 2 or 3% increase. COVID actually increased it a little bit more because so many people are staying home all day long. But demand is going to increase rapidly. You would have to cover the earth with solar panels in order to meet that demand, or wind farms and solar panels. You mentioned that we've got to have the will, and that's a political will as much as it is an economic will for new generation. I don't think we're going to do nuclear in this country. That's an opinion. There are some people that say that's the answer. I think we're going to have to figure out how to get away from fossil fuels because that's also a very political situation in the country. But when you say new generation is going to need to grow up, what do you think the most important thing that the utility industry can do as it comes to new generation? Have you thought about that?
I haven't really spent a lot of time thinking about it. I would say renewables, wind, right. Solar, hydro. Although hydro has its own challenge, all right. of this takes real estate.
Right.
Whether it's a solar farm, it's a wind farm, it's hydro. Working smarter, certainly efficiency, we're looking to that, but I'm going to leave those big decisions up to people who are at a higher pay grade than I am.
Okay, so let's get to the decisions that you can handle. Introspection is probably the premier IR training company in the world. Tell me a little bit about the company, how it got founded, a little bit about your role.
Okay. Introspection Institute is a company that is involved in the training, certification, and support of infrared thermographers throughout the world. Okay. infrared thermographers being persons who use thermal imaging equipment for a wide variety of applications, including infrared inspections of electrical systems to locate areas of incipient failure. Through the early detection, documentation, and subsequent effective repairs, it's possible to help prevent unscheduled downtime associated with outages or defects like loose connections, overloaded circuits,
right,
or unbalanced loads.
Which, by the way, all of the things we talked about are all going to occur more often. Unbalanced loads, unplanned outages. There's going to be a lot more problem as the grid, and you can see here I've got something on the grid edge. That's a conference next year that IEEE PES is sponsoring, but the grid edge is not going to be as controlled, reliable, right, and efficient, you've used the word efficient, as maybe where we could control it in the transmission and distribution. But as a result of that, when you get more potential problems, IR is a great tool for, as I understand it, for detecting those problems before they become shutdowns. Talk a little bit about that.
Sure. Thermal imaging is a form of non-contact, non-destructive testing. It's performed while the electrical system is under load. So this type of testing, unlike other forms of testing and maintenance, requires no shutdown. Right. So we inspect while the system is under load, and in fact, in some cases, the higher the load, the better. Right. Thermal imagers look very much like traditional video cameras, where they, instead of seeing daylight, they sense the normally invisible heat patterns across the surface of any earthbound object. By knowing what is a proper thermal pattern for an electrical component or system, it's possible to detect abnormalities. And through the detection, documentation, subsequent repair, we can head off those catastrophic outages or unexpected outages.
So that's what, if anybody can hold an IR gun, or any kind of a thing, you can kind of train them up about what to shoot and everything, look for ambient temperatures. But talk about those, you certify people, right? You've kind of done the certification program. Then I know other people train up to your certification level, right? How hard is it to teach an operator not just how to shoot, but also how to read? And talk about the levels of certification.
Sure. With respect to training people to perform thermal imaging, the equipment today is fairly user-friendly and fairly straightforward. And in the electrical applications, we're typically comparing similar components under similar load to one another, looking for inexplicable differences.
Right.
And if you can readily navigate the Sesame Street, one of these things is not like the other rhyme and game, you can make a pretty fair thermographer. But with respect to the operation of the equipment operation and understanding heat transfer principles and IR theory, that's one aspect. The other aspect is understanding what you're looking at the beginning of the day. It's easier to take and train an electrical professional how to do thermography than it is to train a thermographer all about electricity.
Oh, say that again. It's easier to train an electrical practitioner on thermography than take a thermographer and teach them electrical. That's important. That's very important. Yeah.
It is. So it's not only understanding the infrared camera's operation, how to utilize it properly, and the theory behind it, but also the proper operation of the electrical system.
That's excellent. What levels? There are levels of certification, correct?
Yes. Traditionally in the United States, we have 3 levels of certification, 1, 2, and 3, with 3 being the highest.
Okay.
In Europe, they've taken a slight sideways adaptation, and they're called category 1, 2, and 3, with 3 being the highest. Okay. Our certification programs for all levels train people in the proper use and application of thermal imaging equipment across a wide variety of applications. Electrical is something we cover very heavily in our level 1 course. Okay. We also carry on and teach more advanced temperature measurement. Okay. And setting temperature limits in our level 2. And level 3 is a best practices course, complying with standards that are in place not only here in the US, but also worldwide. Okay.
Last question I've got for you as it relates to IR. Ultrasound is a new technology coming into being, and there seems to be somewhat of a merging between IR and ultrasound, especially as it relates to electrical systems. Talk a little bit about that.
Sure. Thermal imaging is but one of many tools that can be used proactively for helping to ensure the health of electrical assets. Yeah. Ultrasound is another type of non-contact, non-destructive testing, which hears frequencies above the human hearing range.
Right.
And things such as partial discharge, corona, or tracking, all conditions which are
potential faults.
Potential faults. Thank you.
World,
right.
Yeah.
So potential faults. The ultrasonic equipment detects those and provides documentation of their existence. So again, through the early detection, documentation, and subsequent effective repairs, one can head off problems associated with these types of conditions.
Okay, I have a statement. You can say true, false, or meh, could be, right? IR sees things that you cannot hear, and ultrasound hears things that you cannot see.
I would say yes.
That's great. Our guest today, this is Jim Seffrin, a friend who's been with us a while. But Jim, thank you for joining us. Infrospection Institute.
Thank you, Alan.